Guys, I think we could all agree. Something's going on in this problem. Do we see multiplication? Can we at least multiply them? Who knows what's going to happen? But we all know there's multiplication. Why don't we just try to multiply them and see what happens? And again, if you're kind of getting confused, let's just think of secant as x, tangent of y. Can you multiply x minus y times x plus y? Yeah, that's difference of two squares though, right? Yes? So that means really I just need to square the first term, subtract the square of the second term. So really what this looks like is secant squared of y minus tangent squared of y all over secant of y. Now, did that get us to the right side? No. But that's something we did. But guess what? Just by doing that, guess what that just now opened the door up to? Now I have squared, Pythagorean squareds, right? Yes? Yes? No? Yes? OK, so tangent and secant, those are part of Pythagorean identities. How are they related? Anybody have 1 plus tangent squared of, let's do y, is equal to what? Secant squared. Now, notice how I'm using my Pythagorean identities with y's. I'm not using thetas or I'm not using x's. Because, Cody, it doesn't matter which variable you use. In this problem, we're using y, so that's why I'm going to use that. Would it be OK, guys, if I replaced secant with 1 plus tangent squared? Yeah. Would that be OK? Is that legal? Yes, of course it is, right? So tangent squared of y minus tangent squared of y all over secant of y. Well, these subtract out. I'm left with 1 over secant of y. How is 1 over secant of y equal to cosine? Well, is really the reciprocal, like 1 over secant is really the same thing as 1 over cosine, right? Yes? So I would be OK with you verifying from that point. You could rewrite it as that's equal to cosine, do one more step further, which is fine. But when you have like a single identity, that would be fine. And like if it was a multiple choice question, like if it was simplifying,